Hi, in this video, let us sketch the graph of a function given certain conditions that the functions should satisfy. So let's look at this example. We would like to draw the graph of a function f so that f of 1 is equals 2 and the limit of f of x as x approaches 1 from the left is 3 and the limit of the function as x approaches 1 from the right is -1. So, since only 3 conditions are given about the function, we really can draw many functions that would satisfy these properties. So right now we'll only work on drawing the graph of one function. That would be our example of a function whose graph satisfies these three conditions. A good way to proceed is look at this piece of information and see which one we want to use first. Let's look at this. F of 1 equals 2. That is giving you a particular point on the graph of the function. Input is 1, output is 2. That means the point 1, 2. X coordinate is 1, y coordinate is 2. So this particular point does lie on the graph, must lie on the graph. So I've marked that point. Now let's look at how to create our graph from this piece of information. So these two pieces of information tell you the behavior of the graph very close to an input of 1. Exactly at 1, we know the function null value is 2, so that point is on the graph. But very close to 1, so let's look at this piece of information. However we draw the graph, if we begin to have x approach 1 from the left, and if you looked at the functional values of those points, those functional values should begin to get very close to 3. So that means by the time you're very, very close to 1, if you go up to the graph, you should see this kind of a picture. An open circle that represents that. And to the left of it, you could really create your graph any way, starting out from that point, any way you like. So I'll just draw something like that. That could be my piece to the left of it. Notice if that is a piece of the graph, notice this condition is satisfied. Limit of f of x as x approaches 1 from the left. If you go up to the graph, it is indeed 3. So that is satisfied. Now we use the same philosophy to use this information to sketch the graph, how it would look on to the right of 1. So as x approaches 1 from the right, that means when we're somewhere here, if you would like to look at the functional value, it should be -1. It should be -1. So that means something like this, open circle. And to the right of it, you can draw the graph any way you like. I'm just going to draw it that way. So there is one example. As you know, many examples can be drawn. It's just a matter of changing this piece and this piece. This point is fixed, but you can make variations to that and you'll get a different example. So many graphs would be correct answers to such a question. Now let's change the question slightly. Let us get rid of this information. That would be the second example. And this graph continues to satisfy these two properties, so you could keep this. Or if you like, you could erase that point. Now those two pieces together, that is the graph of a function for which these two properties hold. So that's a correct answer. Furthermore, if you like, you could also fill in one of these dots if you like. That would also be the correct answer. Or you could leave that as an open dot, open circle. So that point is not part of the graph, and you could fill in the circle. So 1, -1 is part of the graph. You could do that. You cannot fill in this point and this point, because then we would not have the graph of a function. For an input of 1, we can only have one output value. So either you can have this, and this is a correct answer for a function whose graph satisfies these two properties. If you like, you could fill in one of the two dots. That would also be a correct answer. Many answers are possible. Thank you.